We're talking about automobile accidents. We hate to think about accidents happening, but we probably all had the experience of at least having a little fender bender. Sometimes it's very difficult for the highway patrol or the insurance companies to decide who in an accident is at fault. Have you ever noticed that the highway patrol will often come out and measure the skid marks of cars in an accident? What are they measuring? How does that apply to science? Well, recall that Newton's third law, that forces occur in pairs, is also called the law of momentum. Now, any object which has mass and is moving has momentum. Even something as small as this toy has momentum. If I move the clackers here, they will move, and because they have a mass, they have momentum. But if I keep them moving and the clackers hit each other, the momentum doesn't disappear. Notice that when the pink ball hits the green ball, the motion is changed from one ball to the other. Momentum is conserved. It doesn't disappear, and so the momentum here is actually being transferred from one ball to the other. In fact, this is very colorful, and you can see this because you see green, pink, as the balls hit each other and transfer their momentum. Well, now you say, what does that have to do with measuring skid marks? Let's see. I have here a little dart gun. In fact, it doesn't have a dart on the end. Rather, it is a plastic tube with Velcro on the end. We all know that any projectile like this, anything that's shot, has an extremely fast velocity. Let me show you. When I pull the trigger of this dart gun, watch how fast the dart moves. If you were to try to time that, unless you were timing it electronically, you would find it very difficult to time because that has a very, very fast speed. But there is a way we can very easily time this same object using the speed of another object. I have here a car, a toy car, that also has Velcro on the back. If I hit the car with the dart, the Velcro will connect and the momentum of the dart should be transferred into the car. The car has mass, so if it now gains momentum, that should move its mass. It should have a velocity. The dart has a very light mass, but as you can see, it has quite a velocity. Okay, let's see what happens when the dart hits the car. Let's see if momentum is transferred. And as you can see, the dart hitting the car transfers its momentum to the car and makes the car move. Now the car is something whose velocity is very easy to measure because it's moving much more slowly than the dart. Let's do an instant replay on that. We hit the dart with the car with the dart, the car moves. The momentum of the dart is transferred to the momentum of the car. This is primarily what happens when two cars collide. Let's say you have one car moving along, another one comes near it and collides with it and causes that car to move, and in doing so makes skid marks on the road. Let's go back to Newton and see what this means. Let's see how the highway patrol could come out and interpret this. Recall that momentum is conserved. That means it is not gained or lost. It is simply transferred from one object to another. In the case of the dart in the car here, then, the momentum of the dart equals the momentum of the car because momentum is conserved and the motion of the dart is transferred into the motion of the car. Now, momentum is a function of two things: mass times velocity. So you see it's different from force. If you'll recall, force was mass times acceleration, a change in velocity. Momentum is slightly different. It does depend on the mass of the object, but now there doesn't even have to be an acceleration for an object to have momentum. All it has to have is a velocity. So the mass times the velocity of the dart now is transferred into the car and will equal the mass times the velocity of the car. In advance, I took the mass of the dart in the car, and I found that the mass of this dart is 2 grams. It's really quite small. We don't know the velocity of the dart. Remember, it is going very fast and would be very difficult to time. The car was easy, though. We know that the car has a mass of 20 grams. It moved across the table at about a distance of a meter, and it took about a second. So its velocity was 1 meter per second. That velocity times 20 grams now equals the mass of the dart times its velocity, and you find that the velocity of the dart is actually 10 times that of the car. It's about 10 meters per second. The Highway Patrol is doing the same thing. When they come out and measure the skid marks that have been made by a car, they're able to measure the distance the car went, taking into account the time over which the collision occurred. They can tell the velocity of the original car that was hit. Knowing the mass of the car and the mass of the car that hit it, they can then determine the velocity of the car. So you see, Newton's third law is going to prevent you from getting away with speeding and having the Highway Patrol not know. They can measure the skid marks, and they'll know how fast a speeding car is going.